Clive Scott. I'm responsible at Leonardo Helicopter Division for all new development programs, including all the unmanned programs such as HERO, such as what we're here talking about today. Is the latest upgrades to the AWHero platform. Let's not forget was certified in October 2021 through the Italian military authorities called AWHero. What we certified back then was what we call the basic aircraft, which was based on a known configuration as what we have here today. The new aircraft has the same rotor, transmission, avionics as we had before. What we've done with these upgrades is modified significantly the airframe. The airframe's been modified by changing the feet or the landing gear that the aircraft lands on to improve the field of view and of the optical sensors, but also the stability on the back of the ship. The new fuselage is entirely made out of composite, so carbon fiber, which has enabled us to reduce the weight, but also improve the accessibility for maintainability of the aircraft. So all these panels are removable on the back side of the aircraft that can be removed. They're structural panels, but they can be removed to enable the improved accessibility to all the avionic components. I say avionic because the aircraft has no hydraulics, because it's a fly-by-wire aircraft to all intents and purposes with an electrical system that everything functions electrically. So that's the mechanical aspects, if you like, the structural. The other main aspect we've done here is we've modified the engine. So the first certification was achieved with a gasoline engine, a rotary Wankel engine, but here we've installed two engines, still rotary Wankel engines, but with a heavy fuel configuration right from day one. So now we're operating with a heavy fuel, including JP5, which is the fuel that is used by the ships. So it's much easier to operate than on the back of a ship. The navies generally don't want gasoline, don't want petrol on the back of a ship for fire reasons and fire hazardous. They want to be able to use the same fuel as they're using on board the ship, which is what we have here today. The two engines together provide somewhere between 60 and 70 horsepower, which is more than enough for takeoff and landing. And then in the cruise mode, we can manage that power to reduce the power significantly, where we need about half of that power for the cruise mode. And this is, of course, an aircraft that, once it's taken off from the back of the ship, spends most of its life in a cruise mode, in a search pattern, flying around the ship, protecting the ship, acting as another sensor away from the ship. Now those sensors, of course, is what's most important about a drone, about an unmanned air vehicle. We build these aircraft to have an additional sensor that is effectively a long arm of the ship acting with a radar. And here we have a maritime radar. The radar is built by Leonardo. It's the Gabbiano TS Ultralight. It's a radar that's designed for maritime operations, which is unique in this class. Much better than an optical radar. What is known as an optical radar, using effectively the optical band of the electro-optics. This is a proper maritime radar, which requires more power consumption, but the aircraft is more than capable of providing that electrical power. With that radar, we have an 8-inch electro-optic system, which enables us to go and then look at whatever targets we have found through the radar, identified through an AIS system. We have an AIS system to identify ship transponders, and then go and physically look at that threat or that question or whatever we have detected with the radar with the electro-optic. We're looking at range endurances in the region of 4 to 5 hours with this relatively heavy configuration. We can remove the radar, keep the same structure on the aircraft without changing the nose cone or anything, which again is an improvement we've introduced over the previously certified variant. With a 10-inch electro-optic, which weighs a lot less than this configuration, we can increase the endurance even further, where the mission only requires an electrical optical system. For maritime and military operations, we also have the capability to install a GPS anti-jamming antenna, so an anti-jamming GPS antenna, as well as we've given the aircraft the capability to fly in a GPS denied and fly safely in a GPS denied environment using onboard inertial navigation systems and magnetometers. At the moment, we've started flight testing the aircraft in November of last year with a first prototype. The second and the third prototype are very close behind. The second is ground running this week to fly soon, and the third prototype will fly at the end of this month. So those three aircraft will be used to first expand the envelope and demonstrate the envelope of the aircraft, prove the new cooling systems and the improved aerodynamics we've given to the aircraft. Once we've done that, We will demonstrate shipborne capability, so deck landings and moving deck landings, and then from there we'll go through the formal certification process with the Italian certification authority AWHero to achieve certification around the middle of next year. So we're about a year away from having a product that can actually be delivered to an operator in the field.
My name is Matteo Barbieri. I'm the Managing Director of Calzoni, Italian branch of RUAS. Calzoni is more focused on naval business. We do mainly submarine equipment, mast raising equipment, valves, snorkel system, various handling equipment. We provide handling system on board ships. We provide visual landing aids. Hunterwater is a new concept for mine hunting application. The idea is to have an unmanned system. A surface vehicle is unmanned, is conceptually towing this new underwater vehicle. While is towing the vehicle is doing the search. As it detects a potential target, it becomes an autonomous vehicle, so doing autonomous activities to perform the identification of the mine. As the mine is identified, it releases acoustic beacon close by the mine, and then it moves out of the minefield. Then from the surface vessel, a torpedo is released, and the acoustic beacon is guiding the torpedo close by the mine. When it becomes too close to the mine, it is guided, since the beacon is side to the mine, it is guided by different sensors to hit the target. So the basic idea is to have a small vehicle, 7.5 meter, so compatible to many different ships, not just a big ship, doing a complete mine hunting activity from search to identification to neutralization. Autonomy currently is, of course, it depends on the configuration of the USV, minimum 8 hours. Sea state should be 4. This system works up to 300 meters depth. The system is real, as you see, is completely assembled. It will be sea tested starting from late June. We should complete sea test by Q3 this year, and then it will be ready for demonstration to customer. Many different interests from various navy, because it's really compact and it can be used on board many different type of vessels, so this possibility not to have a big vessel that has to be together with the fleet, moving side to the fleet, or deployable only from big ship, it's creating interest. The AWHero is a typical UUV system, 300 meter depth. We are working to have a deeper depth. This is the 900 version, the biggest one. Autonomy, depending on the configuration, between 8 hours and 16 hours. It has a mission section that can be configured around the mission capability, so it's agnostic to any sensor. You can change the sensor depending on the mission you want to provide. If you want to have mine hunting capabilities, you have a mission package. If you want to have ISR capabilities, you have a different mission session. It's in use by US Navy, and it has been sold to different navies. It can be commercial. Two different families, AWHero 3 and AWHero 4. AWHero 3 is smaller, AWHero 4 is bigger, is the newest version. We have two different sizes linked to the diameter of the vehicle. Bigger it is, of course, more autonomy you have and more room you have for the sonar suite.